Hey guys, and welcome back to a new video. In this video, we're going to continue working with fragments. We're going to learn how we can override the different callbacks of the fragment and use each of them accordingly. Before everything, here's our layout for this video. It is the same layout from the last video. The only thing I did is just adding a color to the fragment container view to just notice the difference between the fragment and the activity. And also, make sure to watch the previous video as we are building on what we had previously. Now, let's start working with the first fragment. So before, we had to pass the layout of this fragment within the constructor of the fragment, and that automatically attaches the layout to the fragment class. So if we are doing it this way, then we can get rid of the onCreateView, as we are not going to override the onCreateView if you are passing the layout to the fragment constructor directly. So in this case, all you have to do is just to override on viewCreated, and here you get access to the view, which is the same layout or the view that you pass to the fragment. And here you can simply just use the find view by ID function. Well, it's not available here because the fragment doesn't directly extend from the view. You have to use the view passed to the onViewCreated function. And here you can say find view by ID. For example, a text view within the layout here, it has this ID, first fragment TV. Let's get here r.id.firstFragmentTV, and you can use the same methods and functions that you would use with a text view like you did within an activity, like a click listener, for example, or change the text or the font or any other properties. Now, what if you don't want to do it this way by passing the layout to the constructor? For this, you have to override the onCreateView. And as we learned before in the previous video, that the onCreateView function called when the view of the fragment is first created. So here, instead of doing this, let me get rid of this layout. And here we are going to inflate the view and return it within this onCreateView. Now you can notice that the onCreateView passes three things to us: the inflator, container, and the saved instance state. So we are going to use the inflator and the container to inflate the layout. Here, by using inflator.inflate function, and within the inflate function, you can see it has a couple of overloads, and we are going to use this one here that takes a resource, a root, and attach the root boolean. So the first one is the resource, so pass the same layout, r.layout.fragment first. And here we have to pass a root of type viewGroup, so we're going to pass the container, and finally we have to pass attach to root, either false or true. So what is this attach to root? Attach to root says that the layout of the fragment should be attached to the root layout, which is the activity. In this case, we are passing false because this is not our responsibility to do this. It is the responsibility of the fragment manager, as it attaches the layout automatically to the root layout, which is the activity, as we have seen in the previous video. Now, once we did this, we can see that the inflate function returns a view. So we could either store this within a variable, then return this variable, or we could simply just return the whole function here, or the return type of this function. And again, within the onViewCreated, you can perform your operations on the views. Now, let's implement viewBinding within fragments. And if you remember how we did it for our activities before, we only had 3 steps. First, we had to declare the binding and the binding type, which is in this case activity main binding. Then we had to initialize the binding and pass the layout inflator. And finally, we passed the root of the binding to the setContentView function. Then we could seamlessly use the binding anywhere within our class to interact with our views. Now, in activities, it's slightly different. It actually consists of 4 steps. First, we declare, then initialize. Thereafter, we return the root within the onCreateView function. And finally, we set it to null within the onDestroyView function. We're going to have a further yet brief discussion of why we do that. So let's start. Here we declare the binding. So private var binding. It is of type fragment first binding. So as you know, the binding name comes after the layout name. So fragment first binding, fragment first binding. Now, in our main activity, we had to declare it with a latent modifier, saying that we are going to later initialize it. Now, within fragments, we cannot do this. We have to initially make it nullable or null. So to make it nullable, we have to add the question mark here to say that this binding here is of type fragment first binding that can accept null values. So why aren't we using the latent modifier here? Where if we use the latent modifier, then we initialize the binding here within the onCreate view. That means the binding will be available as long as the first fragment class is available, and that's correct. But as the documentation states, fragments outlive their views. So that means the views of the fragment are destroyed earlier than the fragment. So later when a fragment is being recreated, a new view will be recreated for that particular fragment. If we use the latent modifier and the fragment quickly got recreated, then we could possibly have a reference to the previous fragment's layout that was destroyed, and that would lead to a memory leak and possibly a crash. So setting the binding initially to null and finally to null when we done using it ensures a proper memory management and avoid potential crashes within our app. Now let's move to the second step to initialize the binding. So here within the onCreate view, we are going to initialize the binding equal to fragment first binding dot inflate. And here we can pass the same parameters as before. The first thing is the layout inflator, so pass the inflator here from the function. Next, you can pass a parent group, pass the container, and finally pass false for the attached to root. Now the third step is to return the root of the binding within the onCreate view. So instead of this line, return binding dot root. So here you have to add the question mark to check for nullability. The last step is to override the onDestroy view and make binding equal null or set it to null. Now to quickly verify that the onDestroy gets called, let's just make a toast message. And here I'm just going to comment this line of code. Here we have to pass a context. So fragments doesn't actually inherit from the context class, so we cannot pass a context. We have to pass require context, which gets the context from the host activity, which is our main activity. And finally here, I'm going to say onDestroy. Now let's run to see how this works. So here you can see the first fragment. If you go to the second fragment, you can see the onDestroy gets called, and now our views are dead, but our first fragment might be there in memory, the class itself might be there in memory, and this is why we have to set it to null once we finish using it to avoid potential memory leaks and crashes. Let's continue here within the onViewCreated. Now we can simply interact with our views by using the binding. You can see here we get access to our view, first fragment TV. You can now change the text or any other properties. But you can see here we notice one thing, that whenever we have to call any view, we have to add the question mark, and that can be quite annoying. So it is advisable to rename this variable to _binding and create another variable, make it private val binding, which is of type fragment first binding, but in this case is not going to be null. And here we are going to set it to the binding, which is the _binding, and then we add the double exclamation marks to say that is not going to be null. So what is that? Well, this will let us avoid having to add the question mark whenever we use the binding. This is the first thing. The second thing, we use the get function or operator, which is a feature of Kotlin that converts this into a getter method automatically to get the latest value of the binding. And here we ensure also that the binding that we get is not nullable. So we can seamlessly use the binding that we created without having to add the question mark over and over again. Now you might say that this might cause a null pointer exception, but since you're using the binding from the onViewCreated until the onDestroy view, then using this binding is valid and it will not cause any issues. And now just to have a quick example, let's add a click listener to our text view to change the text whenever we click on it. So set on click listener, and here if you clicked on it, we want to change its text. So binding.firstFragment.text. equal to I am clicked. Here, click on the first fragment and you can see it changes to I am clicked. Now, if we navigate to another fragment and go back, you can notice that the state of the fragment is lost, even though we added to the backstack, so it should save the state automatically. However, the state is preserved if any configuration change happens, like screen rotation, for example. So how we can preserve the state whenever we navigate to another fragment? If you remember before in the first videos of this playlist, we had to preserve the state of the activity by using two methods. First one is by overriding the onSafetyState and onRestoreState. The second one is by using a viewModel. And within Fragments, we also have onSavedInstantState. However, it is called in conjunction with the activity onSavedInstantState, so it wouldn't be reliable to save the state of the fragment. So let's use the viewModel to save the state of the fragment in this case. Here, I'm going to create a viewModel related to this fragment only. I'm going to call it first fragment viewModel, or first frag viewModel for short. It's going to extend from the viewModel class. And here we are going to have a var text equal to empty string initially. And now within the onCreate, we are going to create our viewModel. So override the onCreate to add our initialization code. Here, let's make the viewModel as a property within this class. So private latent var viewModel is of type first fragment viewModel. I can notice that we use the latent modifier with the viewModel. In this case, since the viewModel is just a plain class, it doesn't have any connection with the UI, it's fine to be alive as long as the first fragment is alive, and it will not hold any reference to the view or anything that is related to the display. Now, here within the onCreate, viewModel equal to viewModel provider. Here it requires an owner. So who is the owner of this viewModel? In this case, we can say that this fragment is the owner of this viewModel. So that means as long as this fragment is alive, then the viewModel should be alive. Then we can use get and pass the type of the viewModel. So in this case, first fragment viewModel :class.java, or you can simply just say get without passing the value, and it will return an existing viewModel or creates a new one for this owner, which is the fragment. Now, whenever we click on the button, we want to first set the text of the viewModel to I am clicked. Then we set this text to the text automatically. Now, whenever we navigate to another activity and come back, you notice that the view gets destroyed. So that means the view will be recreated. Therefore, the onViewCreated is also called. For this, we are going to check if we have some value within our viewModel to set that value to our text view initially. So first, we're going to check if viewModel.text is not empty. So it's initially empty. If it's not empty, then we set some value to that text. Then set that value to our text view. And now let's run to test this code. So here, click on the fragment. It says I'm clicked. Go to the second fragment. You can see that the view is destroyed. If we get back to the fragment, the onViewCreated is called and it checks if the viewModel has any value and set that automatically to our text view. So let's go back. I can see here that text is now set and we preserve the state of the fragment. So that was it for this video. Thank you for watching, and I hope I see you in the next video.